Hello. Today here in this video, we are going to learn how to calculate conditional probability when a probability distribution table is given. In our previous example, in an earlier video, I demonstrated how to calculate conditional probability using frequencies. But now, instead of frequencies, we suppose we have probabilities. But in conclusion, there is no difference. You may use those probabilities as if they are frequencies. There is no difference at all. So, in our high cholesterol and smoking example, let's calculate the probability of high cholesterol given that the person has smoked before. So the condition is as smoking. That is, this column, second column, will be deleted, right? So same as before. And among those observations, how many have high cholesterol? 37.99. You may think it just as a frequency. So there are 37.99 observations in our data that satisfy this main event. So then just calculate the ratio. It's exactly the same algebra as if you are using frequencies, right? So in the end, we have 80.11%. So among those who have smoked before, more than 80% have high cholesterol, right? And then what you can see from here is that we have the same formula for conditional probability regardless of whether you have probability or frequency. So frequency and probability play the same role in calculating the conditional probability, right? I'm not going to explain more details about that. So same idea, exactly the same thing. Now it's your turn. So try to calculate now the conditional probability of high cholesterol given that a person has never smoked. So do it. Uh, Stop the video now and resume when you finish your work. Okay? Okay, so I'll assume you have answered, you have chosen an answer. So to calculate that, have a look. So the denominator, if you use the formula, you may use just this formula like this. Denominator is SC as complement probability, which is these probabilities. Sum of these two guys, right? That's denominator. And numerator has among these observations that satisfy the condition, 37.49 also satisfies the main events, right? As well as the condition. So what you have to calculate is 37.49 out of 1509 plus 37.49, right? Like this. Simple math, and you have 71%. So then, in this data, we can compare, we could calculate two conditional probabilities given smoking and given never smoked. And the probability of cholesterol differs this much, 80% to 71%. So, like just based on these observations, we may be able to say smoking can increase the probability of high cholesterol. By the way, of course, this is just an example for introductory statistics, introductory economic statistics. In practice, in real medical studies, of course, much more complicated methods would be used. So the medical, scientific results are not as simple as this, but this is the main idea, right? I'm just telling you, uh, right? And so remember, this is the formula we derived And then what we can calculate based on this formula is this formula. So simply by rearranging the denominator, move this term to the other side by multiplying that, then you can isolate the probability of intersection between A and B. So the probability of intersection can be written as probability B times probability A given B. And then we can also interpret this in this way. So the left-hand side, probability A cap B is the probability that A and B happen at the same time. So it's like a simultaneous happening. For example, just to conceptually understand. On the other hand, on the right-hand side, you may understand the right-hand side as a sequential happening. Like first, like we calculate the probability of B happen or not. See whether like first I check if B is true or not. And then after B has occurred, I will calculate the probability of A. Right? It's sequential. B first and then given B happened, then what is A? Right? So that is the meaning of this formula, and we call this general multiplication rule. We call this multiplication rule because probabilities are multiplied. By the way, you may compare this to the general addition rule in chapter 1, and the general addition rule was to characterize the probability of A union B. So addition rule was for union, but now multiplication rule is for intersection. So that's they have like kind of parallel structure, and we are going to come back to this multiplication rule like maybe in the next video. So keep that in mind, and think about the comparison with addition rule. And finally, I'm asking you one more question. What is the probability of not having high cholesterol even if the person has smoked before? So also it is conditional probability, but I included complement, but there is nothing special. Try it by yourself. So good exercise. Okay, if you have done, we can use the formula. Pretty straightforward. So S is the condition, so delete the second column, and then among the first column, we are interested in 9.43%. So numerator has 9.43, and denominator has the sum of that column. And the reason why I'm asking you this is because the result is 19.89%, which is related to another conditional probability we calculated before. So probability of high cholesterol among those who smoked was 80.11. Now, among the same people, among those who have smoked before, probability of non-high cholesterol is 19.89. So that is, these two conditional probabilities have the same condition. So basically, they are using the same observations as their pool, right? Their pool is the same, but out of the same pool, one is looking at high cholesterol, and the other is looking at the other side of the event, right? So as a result, the sum should be 100%, right? Among those who have smoked before, there are only two types of people, one with high cholesterol, the other not, right? So this is not a surprising result if you understand how conditional probabilities are calculated. If two probabilities share the same condition, then the complement should have 100%. That is the complement rule for conditional probability, right? So remember, the condition should be the same. As long as the condition is the same, then complement rule is satisfied as usual, as before, like this. Okay? So this is also pretty straightforward. Just so again, the key idea is you have to understand how the condition works, what role a condition plays, and then like the following results are pretty straightforward and very intuitive. I'm going to give you another example to study some another new concept of independence. So see you in the next video.